The big thing with rational equations is that you have to think about extraneous solutions because you have those x's in the denominator. You can't have a solution that's an asymptote, right? And so you have to check them. And there are a lot of applications that require this, and so that's kind of why we have to do it. Plus, it's just kind of fun. All right, so I don't know if you really need to write this down, this part, but you can decide. When you have to solve an equation with fractions in it, and I started really basic here, there's none on your homework this basic. When you solve an equation with fractions in it, the easiest thing to do is multiply by the common denominator, right? So we can call that the LCD, the least common denominator, or the LCM, the least common multiple. And you get rid of your fractions. It's one of the first things I teach kids when I teach them Algebra 1. If you were going to solve this equation, which is like an Algebra 1 problem, you could just leave it in fraction form. And with calculators, we tend to do that, right? We say, well, I have a calculator, or this one's really not bad because that's kind of a common denominator. But it's way easier to do a problem if you get rid of those fractions. And the great thing about an equation is as long as you do the same thing to everything in the problem, right, you haven't changed the value of it. So if I was going to look at this problem and say, what would the common denominator be between 2 and 5? Come on, I know you know it. Monday after break, common denominator between 2 and 5. 10! Right? You could make them all the same denominator and blah, blah, blah. But the easiest thing to do when you have an equation is multiply everything in that problem by 10. And if you multiply by the common denominator, all your fractions cancel out, and you have no more fraction fears to worry about, and you can just solve that equation. All right? All of our problems today are going to have x's in the bottom, but I just thought we could start with this to remind you that you know how to do this. So, right, I can take 2 into 10, that would give me 5. So 5 times 3x is 15x, plus 5 divided into 10, 2 times 2 times 2 is 4, and 1/5 times 10, or 5 goes into 10, 2 times 1 is 2. Right, that's a super great trick, probably a trick. But it's a super great thing to do. If you see a problem with fractions in it and you don't want to deal with fractions, you're allowed to multiply in an equation, right? The multiplication property says that we can do that. And now that's really simple and quick to solve. You don't have to think about it. You don't have to worry about a calculator to do that. You can just subtract 4, and you can say 15x equals negative 2. Divide by 15. And I get negative 2/15. And I'm not going to get a fraction there. I'm going to leave it as negative 2/15. Now, I said we need to check for extraneous solutions. We don't need to check for extraneous solutions in this problem because there's no x's in the bottom. But we'll look at one in a minute to do that. So we're going to take this same idea and expand it to polynomials, which means we might have a factor. We might have to get a common denominator with x's. But again, it's something that you did in Algebra 2 last year that hopefully isn't that bad to do. Questions on this? Okay. Let's start simple here. Simpler than where it's going to go. And really, there's more than one way to do some of these problems. I'm going to stick with the let's multiply by the common denominator because it's the way that works on even the most complicated ones. Some of you might see very easily on this one that we could just multiply the x over, and that would work on this problem. But if I'm sticking with my common denominator thing, I'm going to say this has a common denominator of 1. Really, that's just a proportion, right? Some one thing equal to one thing that you could just cross multiply. That's another way you could solve this problem. But if I'm sticking with my way here, my least common denominator here between 1 and x would just be x, right? 1x. So if you can find your denominator, common denominator, and you multiply both sides by that, every time, no matter the problem, it should cancel out your fractions. And that'll work on this, right? If I multiply this side by x, I have to multiply this side by x to keep it balanced. So this side cancels out, and I get 15. This side, nothing cancels out, so you just have to multiply, so you get x squared plus 2x, because I have to multiply the x by everything, right? We're only allowed to do that if we do it to both sides, so that's why we have to multiply the x on the other side. Then what would I do to solve this problem? What kind of problem is this? We could put the 15 over by subtracting it, yes. And then factor, right? My hope is that most of these are factorable. Algebra 2, they probably were all factorable. Sometimes they're not going to be factorable, which means you're going to have to complete the square or do the quadratic formula. If you get an imaginary answer, we say there's no real solution, but you could just give me the imaginary solution if you want. But even if it's irrational, you just give me the ugly irrational answer. But I think this is factorable, right? What multiplies to give me 15, that subtracts to give me 2. 5 times 3 gives me 15, plus 5 minus 3. So I get x equals negative 5, x equals 3. You can always check your solutions. I'm kind of bad and I don't always check my solutions. What I do check is I make sure that neither of those solutions give me an extraneous solution up there. An extraneous solution means when you plug it in, like you get 0 in the denominator or you get a negative under a radical. And it's really easy to check. Look in your denominator. What's the only number that would make that extraneous? Or would make that undefined? 7, if I plug 7 in there, would that make it undefined? 0. If x equals 0, then that would be a problem. Do either one of these equal 0? No, so they're not extraneous. Right? That's really all you gotta do. Which means you don't have to do work to do that. You just have to look at it and remember to check. So far, so good? Great Monday back? Great! This is why it's easy for me to record, because it's just like teaching. No, not. Maybe you notice a trend here. Each problem, the first one had no x on the bottom. The second one had 1x on the bottom, and then we're just going to keep adding more stuff here as we go through these examples to show you that this works no matter how ugly the problem looks. What would your common denominator be between x and x minus 3 and 1, if you'd like to say that so far? Definitely I need x minus 3. Does that x minus 3 take care of all those denominators there? Just a little reminder, right? X minus 3 is one factor separate from x, right? So if you're taking your common denominator, you have to take each one. The only way it would be a common factor is if they both had an x minus 3 in them. But this one just has an x, so that's a whole separate factor. So your common denominator has to be x times x minus 3. So the only time that variables are going to have common factors is if they're the exact same thing. Or if one was an x and one was an x squared, we could say they shared x. But addition and subtraction, right, that x minus 3 is separate from that x. Okay, so my same rule applies to this. I'm going to take this common denominator, and I'm not going to multiply it out yet, because I want things to cancel. And I'm going to go through and I'm going to multiply every single part by this. And if you write really small, you might want to just rewrite this. What I tend to do is I just go like this, like I write up here. X times x minus 3. And then next to the 2, I write x times x minus 3. And then next to the 4, I write x times x minus 3. I multiply every single thing by that common denominator. And then one of my favorite parts about math, I get to cross things out. Right? So then I can say x cancels out with x, and I'm just left with 1 times x minus 3. And look at this one. The x minus 3 is going to cancel out with the x minus 3. Remember, that's a subtraction sign there. I'm left with minus 2 times x. Over here, nothing cancels, so I'm left with 4x times x minus 3. Really important step. You find your common denominator, you multiply everything by it. Voila, no fractions. Now you just get to solve it. So I'm going to combine like terms over here. 1x minus 2x would be negative x minus 3. Over here, 4x squared minus 12x. Maybe you see a theme here, as well as the problem's getting harder with each example. It seems like we're going to get a quadratic almost every time, which means you're going to have to factor, complete the square, or do the quadratic formula to solve these problems. So I'm going to move everything over. I like to keep my x squared positive, so I'm going to add x over here and add 3 over here. Agree with that? 4x squared minus 11x plus 3. Yeah? No? Maybe? We could factor this. We could try to factor this. Doing the factor by grouping, if you've always hated that factor by grouping, just do quadratic formula, right? Or complete the square if you want. Divide by 4, that's going to be ugly. But don't feel obligated that you have to do factoring if you really hate factoring, right? But I like factoring. So I would say, do you agree with these numbers? I just put these two together, right? 1x minus 2x to get the negative x, since they're on the same side together. Are there questions about where this came from? Did I? Where's the 6? Right, but this 3 wasn't here, right? Like it was 4x squared minus 12x, and then I added 3, and I added 3 here to nothing. You with me on that? Okay, sorry, I moved it up high, that's why we're here. Other issues with this? I don't have my paper with me to know that I did my math right, so I'm trusting that you're agreeing with my math. Okay, so I'm going to factor. So factor by grouping, I'm going to say 4 times 3 is 12. Oh. I don't think I can factor. Because what happens? Well, multiplies to give me 12, but adds to give me negative 11. No, I needed that to be a minus, right? And it's not a minus. So this is why in other countries they don't ever factor. They always do the quadratic formula. They say, why factor when it doesn't work all the time? So, all right, now I got to do the quadratic. 11 plus or minus the square root of 11 squared, which I believe is 121, minus 4 times 4 times 3, all over 2 times 4. What's great about having to do the quadratic formula is we don't really have to worry about extraneous solutions here because it's not going to be pretty, so that's not going to make our denominator equal to 0 here. I got the square root of 73 here. Did you get that? 16 times 3 is 48. Great thing about this problem is 73 does not have any perfect squares in it. So that means we don't have to simplify anything. We just get this really ugly answer of 11 plus or minus the square root of 73 all over 8. That does not make my problem extraneous. So those are my two answers. Questions about that? Very easy to make little mistakes as you go through there, little addition mistakes or negative mistakes or combining like term mistakes. So show work, right? Show work so that I can see what you're doing. So if you don't end up with the same answer, that I can see that you had the right process at least. How about this one? So far our examples have been pretty, the denominators have been very straightforward, right? Like just a number or a letter or a binomial with a degree 1 there. But this one, almost as complicated as it could get, in that you might have to factor, right? So you don't ever want to say, I'm just going to take a denominator that's like, not necessarily the least common denominator, right? So what happens on this, don't write this down, but what happens is people say, oh, well, I have to take an x plus 1 and an x squared plus 1, and they want to write their denominator as this. Right? Do you remember that rule from elementary school when you had denominators, like worst case scenario, you just multiply all the denominators together and that will always give you a common denominator? Like it works, it gives you a common denominator, but it's not the least common denominator. And what happens every year, people do this, and then they come over here, and you're going to end up with like a 3rd degree or 4th degree or 5th degree polynomial that then you're trying to guess PRZs, and it's just a big mess, right? So this is not okay, because it's not the least common denominator. So if you can factor your denominators, you have to do that first so that you can take out what they have in common. So on this, what I always do is I just go underneath it, and I say, oh, I could factor this into x times x plus 1. So factor first. And then I can say my least common denominator, what do they have in common? Well, they both have an x plus 1, so I only need one of them, right? I only need one x plus 1 to take care of that. But I also need that x right there because it's not in with the x plus 1. That is your least common denominator. This is just a common denominator, not the least one. All right, so in my college algebra class, I know last year we did this, and on the test, someone had this giant polynomial, and they came up and they asked me for help. And I couldn't help them because it was a test, but that's what they had done. They had taken just every denominator and multiplied them together. You know you've done this right if you rewrite this and all your fractions cancel out, right? That's a nice way to check. So I'm going to rewrite this once it's a mess here. I'm going to say 2 times x plus 1. I don't know why I have so many parentheses there. Minus 1 over x plus 1 times x plus 1 equals 1 over x times x plus 1. And notice I'm going to use my factored out denominator, x times x plus 1. Again, really important step that you know you're multiplying every single part of that problem by the common denominator. And then you get to cross out everything that crosses out. So the first one, nothing crosses out. So I get 2x times x plus 1. You can distribute if you want. My x plus 1's crossed out. So I'm just left with minus x there, right? And then over here, super great, all of that crosses out. Then I'm just left with equals 1. Questions about that? Same idea every time, no matter the problem, when you do that common denominator. So I'm going to come over here, all right? And I'm going to say that's 2x squared plus 2x minus x equals 1, or that's 2x squared plus x minus 1, right? So I'm just combining those like terms and subtracting my 1 over. Factor complete the square, do the quadratic formula. I think that was factorable, right? Should we times 1 is negative 2. So we could say 2x minus 1x, right? 2 times negative 1 gives me negative 2. 2 minus 1 gives me positive 1x in the middle. Or again, just do the quadratic formula if you prefer. If you feel like you always mess up back to right grouping. Erase this part too. So grouping these together, I can take out a 2x, and I'm left with x plus 1. And I can take out a negative 1, and I'm left with x plus 1. So take out the x plus 1s, put together what's left, right? So if you did the quadratic formula, you should get really nice answers. You should get a perfect square under your radical. So that means I want you to work it out to get the two answers. You should get negative 1 and positive 1 half. They want me to work out the quadratic formula? So this is the first one that you really got to check those extraneous solutions, right? So look at our two answers, and then look up at that original problem, and you should see that one of those answers is not going to work, because if I take negative 1 and I plug it in right here, I'm going to get 0 in the denominator. So if I get 0 in the denominator, that is not a solution to that equation. So you have to cross that answer out, or you have to make sure you let me know that x equals 1/2 is the only solution to that problem. All right, so that's one of those things you just got to be really careful of. Check your solutions. Questions on that? Maybe there's another one to do. Oh my goodness, this one looks exciting. Factor first on the bottom, so as you write this down, I'm gonna not do this yet. But factor that other side and see if you can get that to work out to something. I remember when I taught this section in Algebra 2, people said it always worked, right? Like no matter, they said every problem, if you have 2 over here and something over here that needs factored, like it's always going to factor into those 2. It happens a lot. It's not always going to factor into that. It could be one is alike and one's not, and you have to do a lot more work. But a lot of times it does work like that, so that's kind of a good way to check there. What's really nice about this problem is now a lot of things are going to cancel out, right? Our common denominator, we only need 1x plus 5. We only need 1x minus 2 because they have those in common. So if you go through and multiply by that, you should get lots of stuff to cancel, right? And again, it's kind of up to you on how you want to write that. I always write it up here. I have people every year that tell me they only write up there what they know is going to be left after they cancel it out. And I get that, but I just want you to make sure you understand where that's coming from. And so for me, I'm going to write everything and show that it's canceling out. You're kind of just going a step ahead and canceling that part out of your head. That's okay. But for me, I go through and I write it all so that I can see that I'm canceling out my fractions in the bottom there. So I'm canceling out that x minus 2. I'm canceling out that x plus 5. And some people just, again, like I said, automatically just say 3x times x minus 2 and do that part. And then over here I just get equals 7, right? less work than what we've been doing, all the PRZs and dividing things out, and it's still a little bit of work, but to me it seems like a nice change of pace from what we've been doing. But you just got to be careful with your algebra. 3x squared minus 6x plus x plus 5. I subtract that over. 3x squared minus 5x minus 2. Remember that? Again, it seems to be most of these problems have a number in front there, so it's either factor by grouping or factor Emma's way that she taught us, which was kind of cool, or quadratic formula. Questions about that? Have you solved it out yet? Do you want me to show you the way I was taught to factor this? No, I'll just screw you up. It really kills me on these. I always just did guess and check on these. So when the first number is a prime number and the last number is a prime number, I hate factor by grouping because I can do it without factor by grouping. It's super quick. But I used to show people this every year and it freaked them out. So I'll just stop. I won't do it. I'll just do the factor by grouping way. Well, multiply to give me negative 6. That subtracts to give me negative 5. That'd have to be negative 6x plus 1x, yes? Not 3 and 2, because 3 and 2 would have to be a plus sign there. So be really careful on when it's 5 and 4. 6 times 2. 3x squared. So I would take out a 3x, and I would get x minus 2, and I would take out a 1, and I'd get x minus 2. So I get x minus 2 times 3x plus 1. When I was taught to factor, you always just made your 2 parentheses and you just guessed and checked. Like you just plugged in numbers until you got it to work. So if it's a 3 in the front, it has to be a 1 and 3. If it's a 2 in the back, it has to be a 2 and a 1. So it's only choices. So then you just have to figure out which one goes where, so your sign will be right for the middle. Really hard to do if the number's like 36 because there's a whole lot of choices. But when they're prime, they're not that bad to do. But anyway, you get x equals 2 and x equals negative 1/3, which is the same answer you should get with the quadratic formula. And if you're faster with the quadratic formula, do that. Lorenzo's in my 6th hour class. He never factors. He always does the quadratic formula. And last year, who was the foreign exchange student last year? How quickly I forget. Oliviero. He never factored either. He always did the quadratic formula. And pretty much every foreign exchange student I've ever had never solves equations this way. Because they don't factor unless it's right the factors. To solve equations, they always do the quadratic formula. Don't forget, when I came over here, to go back and look at that original problem to see if you need to cancel them out. If it's ugly answers, you don't need to cancel anything out because it's not going to be extraneous. But x minus 2 means I have to cancel this out. The last section in this book is solving inequalities, which means you have to be able to solve stuff like this, but also you have to find like where you would shade in, which means you have to take into consideration what x can't be plus what x is, and instead of those intervals, like I think maybe we've done somewhat before. Who knows? I feel like I have like never-ending examples today. Oh, this is for you to do. All right, this is for you to do. Only I don't have clickers for you, but don't say the answer out loud. But when we're done, we'll do like A, B, C. And then this is my last one. I'll do it too. Grady. I brought in my Kroger Employee of the Year award that I found, and I'm pretty sure Grady stole it. 1998 was this award, and I just found it, and I'm pretty sure he took it. I'm gonna pretend to write it up for you. How are you over there, kids? Good there? Oh, that's right. Thanks, good naked one. Anything was going awry there? This is right. This one next to me. Oh, I forgot that. So that's plus. Yes, yes, there you go. That's a Q. That's a Q. Like 2 more minutes and see if we can have a vote on the answers. Okay, we're gonna do like A, hold up one finger, B, 2 fingers, C, 3 fingers, D, 4 fingers. Are we close to being ready to hold up fingers? All right, if you have an answer, hold up your A, B, C, D. All right, keep that ready. If you didn't know process of elimination, you should be able to eliminate some extraneous solutions, right? And this would be like a multiple choice question that they would give you the answers like this, because if you work it out, you actually get B as your answer, right? Both 2 and -5/3 work. But if you just look at the problem, you should be able to eliminate A and B as options right away, because 2 is an extraneous solution. So that's right, D. D is the right answer. So I don't know if you like this stuff. I like this stuff. Here's your homework. This is homework 2-7. Again, there's only 2-8 is our last section in this chapter. So 3 through 18 multiples of 3, 24 through 27, 34, and 40. If they say anything about checking graphically, remember that you don't have to do that. Yeah, there's some that say solve graphically. We're not doing that part. So just ignore anything about graphs on here.